Welcome. I'm going to tell you about the Fractal Cosmos. This is what I call the Fractal Cosmos. Now let me tell you what this is not. This is not a black hole within black hole type of scenario where the structure and fabric of space-time breaks down due to the general relativity considerations. This obeys Newtonian type physics. It's a very simple model of a fractal cosmos, and it contains hierarchy of universes within the overall cosmos. Also, this is not a bubble theory, eternal inflation type theory where universes appear within the quantum field or the quantum vacuum. If you want to learn about those theories, you need to look elsewhere. This is a simple Newtonian physics, Galilean physics model of universes within an overall cosmos, and in fact all of these universes are made up of particles of different orders of magnitude. Now also I want to differentiate that this is not a fractal universe in the sense of the large-scale structure of galaxies as they're distributed throughout our observable universe. That theory may or may not have validity. We can get into some of that at the latter stages of this model after we've understood this model better. That may have some applicability, and when we talk about the early stages of formation of our astronomical universe, but that's not particularly crucial to the development of this model. Also, we've heard of multiverses in terms of Schrodinger's cat type models where we can have parallel universes dependent on which path the quantum probability of possible universes follows, and we're not going to talk much about that. The particles certainly obey the laws of quantum field theory, quantum physics. These particles are in fact standing waves, and we'll go into that. But I just want to differentiate here that we aren't talking about multiverses either. So if you want to know about any of those theories, you really need to look elsewhere. That is not what this fractal cosmos is all about. So let's first make sure that we're very clear on the definitions of cosmos and universe as used here. There can be many universes, universe being it's one complete turn, or one complete level in a hierarchy, and the cosmos would contain all possible universes, not all possible, but all actual universes in a hierarchical series. Now this drawing is not really drawn to scale. This is just to illustrate how smaller particles form very large universes, which in turn form particles which form smaller universes, which in turn form particles, and because of this convergence where the particles are getting larger and the universes are getting smaller, we actually have an end to this hierarchical series, and it's very interesting to look at where that end might be and how we might fit into the big picture of the cosmos. Alright, so for the next episode here I'm going to go into a little bit more about the different types of particles and what a particle is, and we'll build this model from some very simple concepts. There's not going to be a lot of jargon or equations, but physicists who are trained in mathematical physics certainly can apply their tools to better understand this model. And this model certainly doesn't contradict any basic laws of physics that we're all familiar with. Conservation of energy, Newton's laws, these type of things are well within the scope of this model. There's nothing fantastic about this theory. Of course, that's somewhat subjective because you probably have not really thought deeply about this theory up to this point. So that's all I'm going to say right now. I'll see you in the next episode.